Hey all, welcome back in Skolarhive. So in this basic algebra series, this is the ninth lecture and the fourth part of the algebraic identity. So the first three part of algebraic identity, I started from the sixth lecture, seventh and eighth. These are the first three part of algebraic identity, and this is the last part for this identity. So in this video, I'm going to discuss one of the very important identity, and then we'll solve problem based on that, as well as we'll do some of the questions based on what we have done in lecture number 6 and 7 from the identities. So the very important identity is AQ plus BQ plus CQ minus 3 times of ABC is equal to A plus B plus C times of A square plus B square plus C square minus AB minus BC minus CA. Or this can be written in this way also, 1 by 2 times of A plus B plus C, and over here A minus B square plus B minus C square plus C minus A square. So AQ plus BQ plus CQ minus 3ABC is equal to A plus B plus C times A square plus B square plus C square minus AB minus BC minus CA, or this is equal to half of A plus B plus C times of A minus B whole square plus B minus C square plus C minus A whole square. So let's see how we can prove this particular identity. So the first part will first prove, and then the second part is just one step derivation from that one. So let me write the proof from the left hand side. So our LHS is given as AQ plus BQ plus CQ minus 3ABC. AQ plus BQ plus CQ minus 3ABC. So we need to use some of the non-identity to get the result, right? What identity we need to use? Already we discussed in the lecture number 8 that sum of cube of two numbers is equal to, like I'm talking about this identity, AQ plus BQ is equal to what? A plus B times of A square plus B square minus AB. So I'll suggest you all, if you have not gone to the first three part of the identity, first go through that and then come for this lecture. So with the help of this, we can write this AQ plus BQ as sum of the two number times square of first plus square of second minus AB. Or another derivation of this we have seen also, this one also, we can write this as A plus B. Instead of writing A square plus B square, we can write this as A plus B whole square minus 3AB. Minus 3AB. So if we are using this result, the second result, AQ plus BQ is equal to A plus B times A plus B whole square minus 3AB, then we'll get this as A plus B whole square minus 3AB, and next CQ minus 3ABC. Now expand this one. Once we'll expand this, what will come? A plus B times of A plus B whole square will give us A plus B whole power 3 minus 3AB times of A plus B plus CQ minus 3ABC. Now here, this is the cube of the sum of two number, and another we have C cube, right? So if I'm treating this as let's say any number x, then this will become x cube, and this is C cube. Again we are getting the sum of the cube of two number. So let's try to rearrange this. This is A plus B whole power 3 plus C power 3, and then distribute this one, will get it as 3A square B minus 3AB square minus 3ABC. So again, if I'm using the same identity, this identity, first result, what we'll get? We'll get as first number plus second number. First number is A plus B, second number is C. Now the square of first number, a plus b whole square plus square of second number, c square, minus first number into second number, a plus b times of c. And then in this 3 term we can find that 3 times of ab is common in all these 3, right? So minus 3ab, if I'm taking common, what will left? A plus b plus c. Now here this 2 term, this first term and second term, having the same term a plus b. So if I'm taking a plus b common, a plus b plus c common, we left with this one minus 3ab. So this expression is nothing but a plus b whole square is a square plus b square plus 2ab plus c square. So I'm writing this as a square plus b square plus c square, and 2ab, writing this over here 2ab, and expanding this one minus ac minus bc and minus 3abc. So once we simplify this, plus 2ab minus 3ab is going to give us minus ab. So this is a plus b plus c times of a square plus b square plus c square minus ab minus bc minus ca. AC or ca both are same. So this is what the first result, right? So we are done. So what we have done, we just use this identity in a proper way, and then we have done the rearrangement, and then we got the result. Now the second part is a plus b plus c, half of that times of a minus b whole square plus b minus c whole square plus c minus whole square, c minus a whole square. So this part can be derived by just taking one more step over here. So how we can go for it? Let's see how we can do this. What we'll do in that, this is the second part. Okay, what we'll do, here half ABC is there, right? So it means if I'm multiplying by 2 and dividing by 2, then what will happen? This part you can see over here. Next part, I'm just multiplied by 1 by 2 as well as 2. Then this 2, I mean what I'm doing is multiplying 2 and dividing by 2, right? So this becomes what? A square plus b square plus c square minus ab minus bc minus ca. So half times of a plus b plus c, and this 2 is going to multiply with all of this term, right? So this will become 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Now let's see how we can do this one. So this 2a square plus 2b square, we can further write this as, see this part I'm simplifying as what we want over here, half of a plus b plus c, which is already there. So the second part we need to simplify. Here 2a square plus 2b square plus 2c square is there, right? And minus 2ab is there. So if you look into this, like if I'm writing that a square plus b square, then minus 2ab will give us what? A minus b whole square. So if you see, if you expand this one, a square plus b square minus 2ab, and again as 2a square is there, again I'm writing a square plus c square minus 2ac, right? And then again we have b square plus c square minus 2bc. So if we see a square, 2a square, 2b square is nothing but b square, 2b square, and 2c square. So c square, 2c square minus 2ab minus 2bc minus 2ac, right? But by arranging this, what we are getting? We are getting this number as a perfect square. This number as a perfect square. This number as a perfect square. So this is nothing but a minus b whole square. This is a minus c whole square. This is b minus c whole square. So if we are writing in the as a square of the difference of two number, we'll get the result. This is what? 1 by 2 times of a plus b plus c times of a minus b whole square plus b minus c whole square plus c minus a whole square. And we are done with the second result as well. I hope this is clear. So basically this derivation will help you to think and apply the formula that you have learned, because if the questions given is to use the formulas, then you can use it when it is required. But this derivation will make you to understand the main kind of thinking of the situation. Like here numbers are not there, right? But we have to think in a way that we can come up with the appropriate result by using the like kind of appropriate identity. So this is the first result in this AQ plus BQ plus CQ minus 3ABC is equal to this. So one of the derived identity from this one we have, let me just write down that one. So one of the very important derived result we have, if A plus B plus C is equal to 0 or A, B, C is equal, all are equal, then AQ plus BQ plus CQ is equal to 3ABC. This is very important result. See what? Okay, so I think this identity is clear. This can be written in two different way, the first way and the second way. And this is the very important, which is like going to be used in most of the question solving. Okay, so let's move on to the problem solving based on these identities and some of the identities of AQ plus BQ and other forms as well. Okay, so suppose we have given A plus B plus C is equal to 6 and AB plus BC plus CA is equal to 12, and we want to know the value of AQ plus BQ plus CQ minus 3ABC. So we have given the sum of A, B and C values and the sum of product of AB and BC and CA value. We need to find AQ, BQ plus CQ minus 3ABC. So this identity, you know, this is equal to what? This identity is equal to A plus B plus C times A square plus B square plus C square minus AB minus BC minus CA, right? So here if you find that this value given and A plus B, AB plus BC plus CA, you can take minus common, means this will be the sum of the product of this. But we don't have given A square, B square, C square value. So let's just write these values. This is A plus B plus C is 6 and this is A square plus B square plus C square, minus taking common means what? This will become AB plus BC plus CA, and this value is given 12. So this is 6 times of A square plus B square plus C square minus 12. Now we need the value of A square, B square, C square. So if you see once again, this is sum of 3 number, right? And we need the value of the square of sum of 3 number. I mean, we need the value of sum of square of 3 number, right? So how we can get, if you are squaring both sides, so you might have remembered the identity of the square of sum of 3 numbers, right? So that will give you this, means A plus B plus C whole square is what? A square plus B square plus C square plus 2 times of AB plus BC plus CA, right? So now you can see that this ABC value given, sum of this value given and this value also given. So if you substitute this two value over here, then you will get the value of A square plus B square plus C square. So this is what? 6 square, and this is A square plus B square plus C square plus 2 times of this value is 12. So 36 minus 24 is equal to A square plus B square plus C square, which is 12. So it means we just need to plug this value in this. That will give us the result 6 times of 12 minus 12, which is 0. So 6 times of 0 means what? The result is 0. So the value of this is equal to 0. I hope this is clear. So one thing over here you can find in another way, this identity AQ plus BQ plus CQ minus 3ABC, I wrote A square plus B square plus C square minus AB minus BC minus CA. This can be written in one more way, in terms of A plus B plus C whole square. You see, A plus B plus C whole square is equal to A square plus B square plus C square plus 2 times of AB plus BC plus CA. So if I'm writing this A plus A square B square C square as A plus B plus C whole square minus 2AB plus BC plus CA, then that will give us what? You can see this result also, you can note down. This is also very important result. If you know that result directly, you can solve this kind of question. So AQ plus BQ plus CQ minus 3ABC is equal to A plus B plus C times of A plus B plus C whole square minus 3 times of AB plus BC plus CA. This result, right? So if you see this question, A plus B plus C is given 6, AB plus BC plus CA is given 12, right? If you substitute this value in this, 6 squared 36 minus 3 times of 12, 36, 36 minus 36 is 0, 0 times of 6 is 0, so the result is 0. I hope this is clear, right? So this is also one of the important result. Suppose we have given A plus B plus C is equal to 15 and AB plus BC plus CA is equal to, let's say, 7, and we need to know the value of AQ plus BQ plus CQ minus 3ABC. Then what will be the result? This is the question for you all to solve by yourself. Do yourself. So the three formula given for this one. Okay, if you are using the formula which is appropriate to get the result for this one, and see, the identity is not just for like solving the question. Sometimes we need to choose the identity which will give the solution faster. So as I said, this is having 3 different forms. What are the 3 different forms? First form, A plus B plus C times A square plus B square plus C square minus AB minus BC minus CA. Second form, what? Half times of A plus B plus C times A minus B whole square plus B minus C whole square plus C minus A whole square, right? And the third one, which I discussed just in the last example, A plus B plus C times A plus B plus C whole square minus 3 times of AB plus BC plus CA. I hope it is clear, right? Okay. So now let's move to the next question. Suppose we have given 4x square minus y square whole power 3 plus y square minus 9 whole power 3, and then we have given 9 minus 4x square whole power 3. This we have given in numerator. In denominator we have given 2x minus y whole power 3 plus y minus 3 whole power 3 plus 3 minus 2x whole power 3. We need to find the value of this one. So if we see, it seems to be like a kind of many variables and constants are there and power 3 is there. So do we need to use the like A minus B whole power 3 formula, or what formula do we need to use? So if you see very much carefully, this is, let's say, first number, second number, third number, right? And this is cube of first number, cube of second number, cube of third number. Now just try to see whether like some of these numbers are getting 0. So if any questions comes like this, like cube of some or difference of some numbers in like 3 numbers are in cube, then we always need to check the sum of the bases. If it comes equal to 0, means what? We are getting the result AQ plus BQ plus CQ is equal to 3ABC if A is equal to B is equal to C, or A plus B plus C is 0. So we just have to look into that particular identities and then we'll get the result. Let's see 4x square. Here the question is, this is 4x square. Okay, so if you look into this, 4x square is in plus and here this is in minus. So this 2 got cancelled, means 0. Minus y square plus y square is 0. Minus 9 plus 9 is what? 0. So sum of this, this and this is 0. It means what? If I am considering this one as a, means a is equal to 4x square plus y square, and this one as b, y square minus 9, and this one as c, 9 minus 4x square. If I'm adding all of this three number, a plus b plus c, we are getting plus 9 minus 9 got cancelled, plus 4 square minus 4 square got cancelled, plus y square minus y square got cancelled. This is minus 1. So means this is equal to 0. If a plus b plus c is 0, means what we know? A cube plus b cube plus c cube is equal to 3abc, right? So we can say that the value of this, this and this cube is equal to what? 3 times of the product of this, this and this. So 3 times of 4x square minus y square, and then y square minus 9 times of 9 minus of 4x square. Now let's look into the denominator. Are we finding the same kind of pattern in the denominator? See, 2x minus 2x got cancelled, minus y plus y cancelled, minus 3 plus 3 got cancelled. So over here, if I'm taking this as a, this as b, this as c, so 2x minus y, and this is y minus 3, and this is 3 minus 2x. If you add all of this, a plus b plus c is equal to minus 3 plus 3 cancel, plus 2x minus 2x cancel, minus y plus y cancel, means this is equal to 0. So we can say that a cube plus b cube plus c cube is equal to 3abc. It means the value of this is equal to nothing but 3 times the product of these three numbers. So 3 times of 2x minus y, y minus 3, 3 minus 2x. Now, is this the solution? Is this the solution? No. Now we need to look, is there anything further we can cancel in numerator and denominator? So always make sure to write the solutions in the simplest form. So this is not in the simplest form. We need to look for the common thing. So here 3 cancel, right? Is there any further common in numerator and denominator? If you see 4x square minus y square, means this is what? 2x square minus y square, means this we can write it as 2x minus y times 2x plus y, and 2x minus y is in denominator, that will be cancelled. The same way y square minus 9 can be written as y minus 3 times y plus 3, y minus 3 got cancelled. Same way last one, 3 minus 2x, 3 minus 2x got cancelled, we'll have with 3 plus 2x. So basically this will get it as 2x plus y and y plus 3 and 3 plus 2x. This is our answer. I hope this is clear, right? Okay, so now let's move to the next question. Okay, so before moving to the next question, I'll just suggest you all who all are watching my video, make sure to attempt all the questions by yourself. First pause the video, and whenever you are watching the video, sit with your pen and paper, write down the questions which I'm writing on the board, and try to solve by yourself first. And then at the end, once you are done, then you can watch the video in 1.5x speed, and you can check whether you have done the question correctly or not. If not, then you can watch it and try to understand. The next question is, if x plus y plus c is equal to 0, sum of x, y and c is 0, then we need to find the value of 2x square y plus z plus 2y square z plus x plus 2z square x plus y divided by xyz. So this is the question we have given. The condition given x plus y plus z is 0, then we need to find this. So if x plus y plus z is given 0 means we need to, like, this is somehow pointing out towards some of the non-identity, right? So let's try to first see what is given over here, y plus c. Okay, y plus z and x plus y plus z is given 0. So can we think of this y plus c is equal to minus x from this given condition? The same way, z plus x can be write in terms of y, because this is y. By doing that, we'll get it as like xq, this will become yq, and the same way, if we are doing this, we'll get this as cq, right? So what will happen if we are using this? Y plus z is equal to minus x. So y plus z is equal to what? Minus x. So 2x square into minus x is what? Minus 2x cube. Now the second term, z plus x, can be written as c plus x is equal to minus y, because x plus y plus z is equal to 0. As this is 0, right? So we can write this one, we can write this one as well. So if I'm substituting z plus x is equal to minus y, so this minus y into 2y square is minus 2y cube. This plus is there, right? So plus minus minus 2y cube. And the same way, the last term also we can write it as x plus y is equal to minus c. So minus c into plus is minus c times of a square is c square is cq, so minus 2cq divided by x, y, and c. Now we can find that minus 2 is common in numerator, so we left with xq plus yq plus cq, and in denominator we have x, y, and c. Now xq, yq plus cq we have, and we have given the sum of these number is 0, so we can directly say that xq plus yq plus zq is equal to what? 3 times of xyz. So this is equal to minus 2 times of 3 times of xyz divided by xyz. This xyz got cancelled, so we left with minus 6. So minus 6 is the value of this. Right, this one xq plus yq plus zq I'm writing equal to 3xyz, as x plus y plus z is equal to 0. So we can write xq plus yq plus zq is equal to 3 times of xyz. Okay, so this is simple question only. So now let's move to the next question. Suppose we have given a plus b plus c, a plus b plus c is equal to 15, and we have given a square plus b square plus c square is equal to 82. Then find aq plus bq plus cq minus 3abc value. I think this is a simple question. Just need to use the identity. Which identity need to use? Type your answer in the comment box. What identity we need to use over here? We have given a plus b plus c value. We have given a square plus b square plus c square value. Right, we need a value of this one. We need the value of this one, right? So we can write this as a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Anyway, we need the value of ab plus bc plus ca, which is missing over here, right? So if I'm plugging the value of these two in this will give us 15 times of 82 minus taken common AB plus BC plus CA. Right. So we need to find the value of AB plus BC plus CA from the given information. So here this is the sum of two number and this is sum of the squares of number. This is the sum of three number, right? So if I'm taking the square on either side of this equation, that will give us what? A plus B plus C whole square, means this is A square plus B square plus C square plus 2 times of AB plus BC plus CA, which is 225, and this value is given 82. So 82, if you are sending the other side, that will give us 2 times of AB plus BC plus CA is equal to 225 minus 82. Right. So this will give us 34143. Right. 2 times of AB plus BC plus CA is equal to 143. So we want AB plus BC plus CA value. So which is what? Half of this. So I can say that this 2 goes here. Hence this value is equal to half of 143. So substituting that value will give us 82 minus 143 by 2. So 1, 2. Okay, 15 times 21 divided by 2. So you can cancel this. This will give you 7.5 times of 21. And multiply and write down the answer. Okay. So what we'll get? Just multiply simple only. 75 2 times is 150 and this is 75. So 22.5. So the value of this is 22.5. I hope this is clear. So now move to the next question. This question is very good. The next question is going to be very good question. This was a simple question. So the next 3 question is going to be really very good question. So what I'll suggest is you just need to pause the video, think first, try to attempt by yourself, think and then look into the solution. Okay. Okay. Now the question is, if A plus B plus C is equal to 0, where A, B, C are non-zero real number. A, B, C are non-zero real number, then find the value of A square minus BC whole power 2 minus B square AC times of C square minus BC minus BA. So we need to find the value of A square minus BC whole power 2 minus B square minus AC times C square minus AB or BA value when A plus B plus C is given 0. Okay, so let's try to solve this question by yourself first. Pause the video, give a try and then look into the solution. Okay, so how we'll solve this question? You all have given a try, right? I hope some of you might have got the solution. If you are getting stuck in somewhere, now let's see how we can solve this kind of question. So first of all, we have given the squares of this term minus the product of these two. So let's try to expand this first. What we'll get, this is nothing but the square of difference of two numbers. So I can write this as a power 4 plus b square c square minus 2a square bc. Right? Means first number is square. Square of a square is a power 4. then second number square, bc square means b square c square, and then 2 times of the product of these two numbers. Next, let's try to expand this part. B square c square minus over here. So this is minus b square c square. This minus plus. B square into b is pq times of a. Then plus bq times a. Now this minus plus. Plus times plus is plus acq. Then minus plus minus, and this is ACBA means this is what? A square BC. Okay. Now whether we are getting any like terms in this expansion, we can find that this b square is in plus and this b square is in minus, got cancelled. Now we can find that this is a power 4 bqa plus acq having a common in these three, right? So if I'm taking common a from this term and this term, we're left with aq plus bq plus cq, and then over here minus 2a square bc and minus a square bc is minus 3 times of a square bc, right? So now aq plus bq plus cq we got, right? And we have given this information a plus b plus c is 0, so we can say that aq plus bq plus cq value is equal to what? 3abc, right? So this value is what? 3abc, as the sum of the three number is 0, therefore the sum of the cube of those number equal to 3 times of the product of those number. So this become 3 times of abc, and this is a, so a times of 3abc becomes 3a square bc, and this is minus 3a square bc. Both are same term, 3a square bc plus minus 3a square bc, both cancelled, so we left with what? 0. So the value of this expression is equal to 0. This is our answer. I hope most of you might have got the same answer. Okay, so this just we need to like try to expand the given thing in order to find the values of this kind of expression. We need to first look for if there is any kind of identities there. If it is there, we need to just use that. If it's not there, we need to just go for simplifications and then look into the given condition whether we can use this given information or not. If we can use to make it simpler, we need to go ahead. Okay. So now let's move to the next question. This question is also very interesting, so you need to give a best try from your end. Okay, give your like 100% in terms of thinking and applying what you have learned till now. Okay, so we have given if the sum of four number a plus b plus c plus d is equal to 0, then prove that the cube of a plus b plus c plus d, I mean a cube plus b cube plus c cube plus d cube is equal to 3 times of abc plus bca plus cab. Okay, and d is also there, right? abc bcd, 3 times of abc plus bcd plus cda plus dab. We need to prove this. So given is a plus b plus c plus d is 0, and we need to prove that aq plus bq plus cq plus dq is equal to 3 times of abc plus bcd plus cda plus dab. Pause the video and give a try. So what you are thinking? What is your thought process? How we can go for this? We have given only this information. Sum of a, b, c and d is 0. So we have not seen this kind of any identity. But if you think, we have seen something which is similar to this, right? We have seen that the sum of three numbers 0. Then we have one identity which we discussed in previous questions. Then the sum of the cube of those numbers will be equal to 3 times of ABC. But here in this case we have 4 number, right? So let me start with the LHS first. LHS is given as AQ plus BQ plus CQ plus DQ. Okay. Here 4 numbers cube sum is there. Here 4 number sum is 0. If I think in some other way, I can make this as like this is 3 number. Let's say this A plus B considered as 1 number. Let's say A plus B is nothing but X. Then this will become X plus C plus D is equal to 0. Sum of 3 number is 0. It means if we have XQ, CQ plus DQ, then that will be equal to 3 times of XCD. But here we don't have XQ, means we don't have A plus B whole cube. But here we have AQ, BQ, we can write this in terms of A plus B whole cube, right? So if I'm writing this as A plus B whole cube, then what will happen? We'll get 3AB times A plus B terms as an extra, right? So to balance that, we will just subtract that one, right? Minus 3AB times of A plus B. Now this is what representing as AQ plus BQ only. And the next term is CQ plus DQ. If we rearrange this, A plus B power 3 plus C plus D, CQ plus DQ minus 3AB times of A plus B. Now we can find that, okay, this is the A plus B considered as X, means this is XQ plus CQ plus DQ, and we have given X plus C plus D is 0, means this whole term becomes what? 3 times of A plus B times C plus times C times D, right? So we can write this as 3 times of A plus B C times of D, and this is minus 3AB A plus B. Now the last term is just expand it, and then you will find that, okay, we'll get something which is required. On the right side, see 3 over here, and something is the product of 3 numbers sum, right? So let's try to expand it. When we expand it, this is going to be 3 times of ACD plus 3 times of BCD minus 3AB. Here minus is there, and minus times plus will become minus only, right? So if we see clearly, ACD, BCD we got, ACD, BCD we got, we want CDA, and over here AB is there, we can't get CDA from here, but A plus B is there, right? We can think of this given information, A plus B plus C plus D is 0, so can we write A plus B is equal to negative of C plus D by sending this 2 term to the other side? It means I can say that A plus B is equal to negative of C plus D. So if I'm replacing A plus B with negative C plus D, then this will become what? Negative, negative, positive, 3 times of AB, and this is C plus D. Now expand it. 3 times of ACD plus 3 times of BCD plus 3 times of ABC plus 3 times of ABD. Take 3 common. ACD plus BCD plus ABC plus ABD, which is what we need to prove. Just rearrange, order does not matter. Here ACD, BCD, ABC, ABD, you rearrange this ABC, BCD, CDA and DAB, and we are done. I hope almost you all have got the solution. You understood this solution, right? Right, this proof, right? So the main part was breaking down this one into like sum of 4 term is 0, means we can think of this two as one number, and then this problem resolved into what? The sum of cube of 3 numbers is equal to 3 times of ABC, right? Okay. So this is very good question. So now next question is also very interesting. Now suppose we have given x is equal to 2 plus 2 power 1 by 3 plus 2 power 1 by 2 by 3. Then find the value of xq minus 6x square plus 6x. What is the value of xq minus 6x square plus 6x if x is given as this one? Okay. So this kind of question how will solve? Here the cube of x is there, means given value given is x, okay, and the equation is given in terms of x cube, means somehow we have to take the cube of this, right? So if we are taking cube of this, means right side becomes the cube of 3 number. It's a bit difficult to expand, right? We don't have identity till now, we have not discussed this kind of identity. So what we can do is we can take this 2 to the left, right? Then left side also 2 terms, right side also 2 terms, and the cube of 2, I mean binomials we already learning in like all these lectures, right? So we can do this as x minus 2 is equal to power 1 by 3 plus 2 power 2 by 3. Then by taking cube both side, what will come? By taking 2 power 1 by 3 to power 1 by 2 by 3 whole power 3. So this is a minus b whole cube, and this is a plus b whole cube form, right? So this will become x cube minus 8 minus of 3 times of x times of 2, and then x minus 2 is equal to 2 power 1 by 3 power 3 plus 2 power 2 by 3 power 1 by 3 plus 2 times 3 times of 2 power 1 by 3 2 power 2 by 3 times of 2 power 1 by 3 plus 2 power 1 by 2 by 3, right? So if we simplify this one, what will get? X cube minus 8, this will become 6x minus 6 times of x minus 2, and right side becomes power of power. So 1 by 3 times 3 is 1, so 2 power 1, this is 2. This 2 power 3, 2 power 2 by 3 times of 1 by 3 becomes what? This is not 1 by 3, this is power 3. Okay, so 2 power 2 by 3 times of 3 is what? 3 got cancelled, 2 power 2 is 4, plus here 2 power 1 by 3, 2 power 2 by 3, base same, power will be added. So 1 by 3 plus 2 by 3 is 3 by 3. 3 by 3 means what? 1, means 2 power 1. So this is 3, and this is what? 2. 3 to the 6 times of 2 power 1 by 3 plus 2 power 2 by 3. So this is what? 6 plus 6 times of, here you can find that 2 power 1 by 3 plus 2 power 2 by 3 is equal to what? X minus 2. Okay, so we can replace this with x minus 2. On left side we have x cube minus 8. This, if we are expanding, this will give us minus 6 x square, and minus minus plus 12x. So once we simplify further, what will get? X cube minus 6x square plus 12x minus 8 is equal to 6 plus 6x minus 12, right? So what will get? Just simplify this. X cube minus 6x square, here plus 6x goes to left side becomes minus 6, so 12x minus 6x, right? We want this value only. Okay, so 12x minus 6x, and right side minus 8 goes to right is plus 8, so 6 plus 8 minus 12. So left side is what? X cube minus 6x square plus 6x is equal to what? 8 plus 6 is 14 minus 12 is 2. So the value of this expression is 2. Okay, so just we need to use the identities, and the way that we are using the identity is important. So directly if you are cubing, means you will get stuck, because the right side is a trinomials, and the cube of trinomials we have not discussed that one, right? And the cube of trinomial is bit typical, right? So better we can take this 2 to the left, and then that will become binomial on either side, and we can take the cube of the binomials, right? And after that we have to just simplify this. So the next question is also very interesting. Okay, so next question is simple as compared to the question that I have discussed before last 3 question, right? So suppose we have given a square plus b square plus c square is equal to 10, and a plus b plus c is equal to 4. A plus b plus c is equal to 4, and a square plus b square plus c is equal to 10. Then find ab plus bc plus ca value. What is the value of this one? So write down the answers. try by yourself. So now the thing is, before we are learning identity by identities, right? We are just discussing the identities and using that in the problem. Now once you learn the identities in problem solving, you just have to think which identity is suitable for the problem, right? So as we are discussing power 3 like identities as power 2 identities, sum of two numbers square, difference of two numbers square, right? Or sum of three numbers square. These all identity we have discussed. So out of those all identities in a particular question, which identities is important, which identities is required to tackle the questions, that you have to understand based on the question. So here you can find that a square plus b square plus c square is given 10 and a plus b plus c is 4. We want ab plus bc plus ca. If you recall the identity, this is nothing but this, you can get it by, the square of sum of three numbers identity, right? So you just try to recall, this is what a plus b plus c identity, you remember, is square is equal to what? A square plus b square plus c square plus 2 times of ab plus bc plus ca, right? This is the identity. In this we are looking for the value of this one, means this one. We are looking for the value of this one, right? We are looking for this one, and this is given and this is already given. Just plug this and you will get the answer. A plus b plus c is what? 4. So this is 4 square is equal to, this value is given 10, so this is 10 plus 2 times of ab plus bc plus ca. So here this is 16 minus 10 is equal to 2 times of ab plus bc plus ca. This is what? 6 is equal to 2 times of ab plus bc plus ca. We want the value of this, so 2 will divide 6 by then it will give 3, right? So 3 is equal to ab plus bc plus ca, and we are done. This is the simplest question, right? Okay, so let's move to the next question then. Suppose we have given a minus b is equal to 2 and b minus c is equal to 4. We have given this. A minus b is 2, b minus c is 4. We want to know the value of a square plus b square plus c square minus ab minus bc minus ca. Now let's try how we can find the value of this one when a minus b value given and b minus c value given. It's simple question only, right? I think almost all of you have got the solution for this one, right? So let's see how we can solve this question. First thing, already I have derived this result, the identity I have given for this one. If you have remembered that, means this is easy to solve. Otherwise you just have to like write the given things in terms of a minus b minus c, what information we have given. So let's see first with the identity that I have given for this one. So this is a square plus b square plus c square minus ab minus bc minus ca is equal to nothing but half of a minus b whole square plus b minus c whole square plus c minus a whole square. Here in this question we have a minus b value given, b minus c value given. If we are plugging in that, we'll need the value of c minus a only. If we know the c minus a value, this value can be easily obtained, and it is easy to find the c minus a value. You can see that a minus b is 2, b minus c is 4. If I'm adding both of this equation, then what will happen here? Minus b, here plus b, minus b plus b got cancelled, plus a minus c will give you the value of a minus c. So if I'm saying that this is equation 1, this is equation number 2, if I'm adding 1 plus 2, what will happen? A minus b plus b minus c is equal to 2 plus 4. So b got cancelled, a minus c is equal to 6. So from this two information only we are getting the value of a minus c. Now in this all the value is known, a minus b, b minus c and c minus a. So just plug the value of these three. Half times of a minus b is 2, so 2 square, b minus c is 4 square, and c minus a we got 6, so this is 6 square. So 1 by 2 times of 4 plus 16 plus 36. So this is 1 by 2 times of sum of all this is 56. 56 over 2 is 28. So the answer for this is 28. Okay, so now we are left with only few more questions. We are left with only few more questions in this, and then this identity part will be over. So this question is very interesting. We have given 1 by a minus b plus 1 by b minus c plus 1 by c minus a is equal to 3. Then we need to find the value of 1 by a minus b square plus 1 by b minus c square plus 1 by c minus a whole square. Wow, very interesting question. Just pause the video and try to solve this question. I hope you all have tried this question, how to solve this. Most probably, most of you might get the answer for this one, right? So this simple question, just only thing is we need to look into the given information and what is need to be find, right? If you see 1 by a minus b, 1 by b minus c, 1 by c minus a is 3, and this is 1 by a minus b square. So this is nothing but we can think of this as 1 by a minus b whole square, 1 by b minus c whole square, plus 1 by c minus a whole square value. It means whatever the number we have, this plus this plus this, we are looking for the sum of the squares of those numbers. So let me consider this term as x, this as y, this as z. Means basically this is given as x plus y plus c is 3. And we are looking for this is x square plus y square plus c square value. We have given x plus y plus c value. We are looking for x square plus y square plus c square value, right? And this is nothing but equal to, you can easily say that x plus y plus c whole power 2 minus 2 times of xy plus yc plus cx. Here x plus y plus c value is given 3, so this is equal to 3 square minus 2 times of xy plus yc plus cx. It means that we need to just simplify for this one, right? The value of this is depending on the simplification of this part. So the first one is 1 by a minus b, so this is 9 minus 2 times of, this is what? 1 by a minus b multiplied by 1 by b minus c. Then plus 1 by b minus c times 1 by c minus a plus 1 by c minus a times 1 by a minus b. In order to get the value of this, we just need to simplify this. So we can find that the LCM of the denominator is a minus b times b minus c times c minus a, right? So this is what? 9 minus 2 times of, I'm just taking a minus b, b minus c and c minus a as the denominator. Is it very simple? Or let me write this above, a little bit above. Now let's see, I'm writing the next part over here. So this is equal to what? 9 minus 2 times of LCM of the denominator is what? A minus b, b minus c and c minus a. So the first term is having a minus b times b minus c in the denominator. It means what is missing? C minus a. C minus a. Second term missing what? A minus b. And third term missing what? B minus c. So if we further simplify this, we can find that over here we have plus c minus c cancel, minus a plus a cancel, minus b plus b cancel. It means 0 over a minus b, b minus c, c minus a. So 2 times of 0 is 0, means this value is equal to 9. So the value of this expression is equal to 9. I hope you all understood this one, right? The next question is very interesting question. Let's see, if we have given a plus b plus c is 0, then find the value of a power 4 plus b power 4 plus c power 4 minus 2a square b square minus 2b square c square minus 2c square a square. So let's try to solve this question by pausing this videos, and let's see whether you are able to get the solution for this one or not. So let's see how to solve these questions. I hope you all have gone through the different way to solve this question, right? Most probably, most of you might have got the answer, right? So we need to find the value of this expression given is a plus b plus c is 0. So over here, like if you are going from the given expression, we need to look for the factorization of this thing. So factorizations till now we don't know, right? What we can do is we'll just try to look into the given condition as a plus b plus c is 0, right? With that we can go and try for it. Now how we can solve this question? We have given a plus b plus c is 0 and we want to know the value of this. Let's see, we can write this a plus b in terms of c. A plus b is equal to what? Minus c. Okay, so but we want power 4 in a, b and c, or we want power 4 in a, b and c. Okay, so we have given a plus b plus c is 0. Then we need to find the value of a power 4 plus b power 4 plus c power 4 minus 2a square b square minus 2b square c square minus 2c square a square. So we have given a plus b plus c and we want in terms of power 4 of a, power 4 of b, power 4 of c, and a square b square and b square c square, c square a square. So how we can get the power 4 from this one? We have given a b plus c is 0. We want power 4. Directly we don't know what the power 4 identity is. What we can do is, this is 3 term. Let's try to write this in terms of a binomial, a plus b is equal to minus c. So by taking a square of this, it's easy, right? If I'm taking like a plus b whole square, that will give you a square plus b square. We want power 4 of a. So again, if I'm taking a square of that, that will give power 4 of a as well as b. So what I'm doing is I'm taking a square on either side. That will give us what? A square plus b square plus 2ab is equal to c square. Now we want power 4 in a, b and c. So over here, what we can do is a square plus b square plus 2ab is equal to c square. We want plus in power 4 of c as well, right? So what I'm doing is let's replace these two. A square plus b square minus c square is equal to what? Minus 2ab. So if I'm taking a square on either side now, what will happen? This will become the sum of three numbers square. So I can write this as a square power is 2, a square of square, b square of square plus c square of square plus 2a square b square, right? Minus 2b square c square minus 2c square a square is equal to 4a square b square, right? So this becomes what? A power 4 plus b power 4 plus c power 4. And here this is a square b square. And on the right side, this is 4a square b square. If you are taking this on the left, that will go minus. So that will become minus 2a square b square. So minus 2a square b square, minus 2b square c square, minus 2c square a square. And on the right is 0. So we are finding this value only, right? The value of this expression, which is equal to what? 0. So this is equal to 0. Right. Okay, so let's try one simple questions. And two more questions I'll discuss, and then we'll wrap up this identity part. Suppose we have given a power 4 plus 1 by a power 4 is equal to 119. Then find the value of aq minus 1 by aq. aq minus 1 by aq. So let's try to solve this. We are looking for aq minus 1 by aq, right? So we can write it as a minus 1 by a times of a square plus 1 by a square plus 1, right? So in order to find this value, we need value of a minus 1 by a as well as a square plus 1 by a square. We have given a power 4 plus 1 by a power 4 value. So from that we can find that a power 4 plus 1 by a power 4 is given 119, right? So we want a square plus 1 by a square is what? A square root of 190 plus 2, right? So this is 121 means this is 11. A square plus 1 by a square is equal to 11. Okay, this value we got it, right? So how we got this value? You might have remembered this if we have given x plus 1 by x square plus 1 by x square is equal to b. So we can find x plus 1 by x square. X is equal to square root b plus 2. So with the help of this result, I got this. The same way, I can find the value of a minus 1 by a with the given information. If we subtract both sides 2, then this will become a minus 1 by a whole square, and here 11 minus 2 is 9. So root of 9, which is 3. So the value of this is 3. This is 11. So 3 times of 11 plus 1. So 3 times of 12. So this is 36. Okay. So the last question of this identity series. After this series, we'll start the factorization, and parallelly we'll start the plane geometry as well as trigonometry. So that I'll make a separate playlist for the trigonometry and the plane geometry. So in this playlist of basic algebra, after this video, I will upload later on the factorizations and one last applications of all the things that we have learned up to the lecture number 9. Okay. So suppose we have given x plus y is equal to 5. X plus y is equal to 5, and we have given x square plus y square is equal to 13 by 4. Find the value of x power 5 plus y power 5. Okay. So let's see how we can find the value of x power 5 plus y power 5. So can we write this x power 5 plus y power 5 as x square plus y square times of x power 3 plus y power 3. When we multiply this, we'll get x power 5 plus y power 5, but additionally we'll get x square y power 3 plus y square x power 3. So we need to subtract that. X square y power 3 plus y square is there. So y square x power 3. This two term we need to subtract. So here x square plus y square, and this is what we can write it as x plus y times of x square plus y square minus xy. And over here in this 2 we have x square y square common, so x plus y, right? So in both of this term we can find that x plus y is common, so this is x plus y common. So we're left with x square plus y square times of x square y square minus xy minus x square y square. Now we have given the value of x plus y and x square y square. Only value we need is for xy value. So xy value we can find with the help of x plus y. So x plus y is there. By squaring both sides, what will get? X plus y is 5 means by squaring both sides, x square plus y square plus 2xy is equal to 25, and this value given 13. So 13 by 4, right? So 2xy is equal to what? 25 minus 13 by 4. So this will give us what? 25 4 times 100 minus 13 is 87 by 4, right? So xy is equal to what? 87 by 8 is the value of xy, right? 87 by 8 is the value of xy. So this is equal to what? Xy is 5 times of 13 by 4, right? Times of 13 by 4 minus 87 by 8 minus 87 by 8 times of 87 by 8. We just need to simplify this. Once we simplify, what we'll get? 5 times of 13 by 4. And here what we'll get? This is going to be, if we simplify, we'll get this. See, this is also simpler only. Just let's expand this. Once we expand this, this will come 13 by 4 square. Then 13 by 4 times 87 by 8 and minus 87 by 8 square. So let's simplify this further. So what we'll get? 5 times of 169 by 16, and then this is going to be 32 in the denominator. Numerator is 13 times of 87 minus of 64 times of 87 times 87. So further we can simplify this by making the denominator same over there by taking LCM of 16, 32 and 64, which becomes what? 64. So 5 times of 64 over here, and here this is 4 times of 169, then this is 2 times of 13 times of 87 minus 87 into 87. Then further you simplify this, you'll get the solution for this. Okay, so I hope this all things is clear. I tried maximum to like add the values in this lecture. So what all identities I discussed, and as well as the basics of the polynomials. This series is basically the basic algebra series, which I started from lecture 1, ratios and proportion, and this is the 9th lecture where I completed the identity. So next I will upload video on the factorization on this basic algebra series, and then we'll start the quadratic equations in the next few days as a like a new playlist, and we'll start the trigonometry as well as plane geometry. So stay tuned. If you are finding anything to suggest me, feel free to suggest through the like comment in the comment box, or you can directly reach out to me. So stay tuned. We'll come back very soon with a new video. Bye bye.